Hello everyone, in this video we are going to discuss how to find out the inverse Laplace transform of certain functions. Now in the previous class we had already started off with how to do the partial fraction expansion, and now let's see further problems. Okay, now we can just find out the inverse Laplace transform of this particular function given over here. Okay, you need to find out the inverse Laplace transform of the function given over here. The function is given by s plus 2 divided by s square into s plus 3. Okay, now this is not in a format that we are familiar with, so you have to carry out the Laplace transformation, the partial fraction expansion, and using the partial fraction expansion, it will be in a more familiar format. Now, you can see over here there is a s square term present over here. Okay, there is an s square term present over here. Now, in the cases where there are square terms, by square I mean either it is s square or s plus 3 the whole square. In conditions like that, this is how you have to take the partial fraction expansion. It is given by a by s plus b by s square plus c divided by s plus 3. Okay, now suppose your function was like this: s plus 2 divided by s into s plus 3 the whole square. In that case, how will you carry out the partial fraction expansion? In such cases, you will take it as a by s plus b divided by s plus 3 plus c divided by s plus 3 the whole square. So I hope this concept is clear. This is how you're going to do problems which are consisting of a whole square term, that is s plus 3 the whole square, or it can be an s square. Now, how do you find out the values of the particular coefficients? Now, you can see it is always easier to if you are comparing the coefficients in such cases. Okay, in such cases it is easier to compare the coefficients. How can you do the comparison of the coefficients? You can just take the LCM of this particular portion. I hope all of you are familiar with how to take the LCM. You just see for s and s square the LCM is s square, and you just multiply it with s plus 3. Okay, now you want the first term. You have a first term a, and you need to multiply it with something because you have taken an LCM. What should you multiply it with? Okay, now s square into s plus 3 divided by whatever is there on the denominator of a, that should be multiplied over here. Okay, so you can just see over here s square into s plus 3 divided by s. So here s and s get cancelled and you are getting s into s plus 3. So to get the first term, you have to write it as a into s plus 3. What will be the second term? The second term, again you divide the common denominator or the LCM denominator with s square, that is whatever is there along with b, the denominator of b. Okay, so again you take s square into s plus 3 divided by s square. What do you get? These gets cancelled, you get it as s plus 3. So you have to multiply b with s plus 3. And what will be your third term? Your third term, c into, what do you have to multiply c with? Again, you take it as s square into s plus 3 divided by s plus 3. And what do you get? You get it as s square. So you take c into s square. Now, this particular portion should be equal to your function f of s. So you have to equate it to s plus 2 divided by s square into s plus 3. Now your denominators are going to get cancelled, and I will just expand certain terms only. I'm just going to multiply the s over here with this function over here. So you get s square plus 3s plus b into s plus 3 plus c s square is equal to s plus 2. Now you can start comparing the coefficients. Let's start with the coefficients of s square. The coefficient of s square over here is given. You can just start comparing. You have a, and then there are no terms over here, and then you can see there is an s square over here, so you have a plus c, that should be equal to, what is the coefficient of s square over here? There is no coefficient, so you have a plus c is equal to 0. That is the first equation. Now you can compare the coefficient of s raised to 1. S raised to 1, you can see over here you have 3a plus b, there is no term for s in c, and you can see over here there is a term and the coefficient is 1. That is your second equation. And next you have s raised to 0, that is a constant. There are no constants present over here. There is a constant 3b over here. That means s raised to 0, the coefficient of s raised to 0 is 3b. that should be equal to, there are no coefficients over here, there is a 2 over here, is equal to 2. So you can see that from the third equation you are going to get the value of b, that is 2 by 3. And if you substitute the value of b, if you substitute b in equation 2, you will be getting the value of a. Okay, so on solving you will get the value of a as 1 by 9. And if you substitute this value, you substitute the value of a in equation 1, you will be getting the value of c. Okay, so the value of c will be minus 1 by 9. Minus 1 by 9. So you can see over here you have got the values of b, a and c. Now you can just substitute the values over here, a, b, c. Okay, so I'm just going to move this to the next page. Okay, so you have your function f of s, that is equal to, what is the value of a? The value of a is 1 by 9. So you have 1 by 9 divided by s, and the value of c was minus 1 by 9. So you have, the value of b was 2 by 3. So you have 2 by 3 divided by s square plus minus 1 by 9 divided by s plus 3. Now it is easier to find out the inverse Laplace transform. What will be the inverse Laplace transform? The inverse Laplace of 1 by s. The inverse Laplace of 1 by s is a constant. So that is 1 by 9 plus. What is the inverse Laplace of 1 by s square? Now you are already familiar that the Laplace transform of t, the Laplace transform of t is given by 1 by s square. So if you want to find out the inverse of 1 by s square term, what will it be? It will be t. So you have 2 by 3 t plus. Now what is the inverse Laplace transform of 1 by s plus 3? Okay, so what is the Laplace transform of e raised to minus at? The inverse Laplace transform, Laplace transform of e raised to minus at is given by 1 by s plus a. So if you want to find out the inverse, it will be e raised to minus at, and over here the value of a is 3. So you have over here you're going to have a minus 1 by 9 into e raised to minus 3t. Okay, so this is your inverse Laplace transform of the function that was given to us. Okay, so I hope this problem was clear. I'll be just going through one more problem. Okay, one more problem. We can just go through one more problem. Try to find out the inverse Laplace transform of the function f of s is equal to 3s plus 1 whole divided by s plus 1 into s square plus 2s. Now, over here again you need to take the partial fraction expansion. Now, here you can see that there is no common square. S plus 1 whole square or x square plus 2 whole square. It's not a whole square term. You are having two different types of polynomials. So, how do you take the partial fraction expansion? Now, over here for the term s plus 1, you can take it as normal a divided by s plus 1. But for the next term, you can see that it is a second order polynomial. And it cannot be split further into proper multiples. That is, if you are trying to split it, you will be getting complex terms. So, in such cases, you will be taking it as if it's a square term. If it's a square term, you have to take it as bs plus c divided by s square plus 2. So again, in such problems, it is always easier to compare the coefficients. If you want to compare the coefficients, you have to take the LCM. So how do you take the LCM? It will be the common denominator will be s plus 1 into s square plus 2. Okay, s plus 1 into s square plus 2. And how do you find the first term? A into, it will be s plus 1 into s square plus 2 divided by s plus 1. So s plus 1 gets cancelled and you are going to get s square plus 2 plus you have bs plus c into s plus 1. And this should be equal to your polynomial, your original polynomial. Okay, this is your original polynomial over here. So 3s plus 1 into s plus 1, divided by s plus 1 into s square plus 2. So again, you can just compare the coefficients. Okay, I'll leave that to you. Or should I help you? I think I'll just try and help you. Okay, so I'll just do the remaining portion over here so that it will be easier for me to do the calculations. Okay, so what is the first term? A into s square plus 2 plus bs plus c into s plus 1 is equal to 3s plus 1. I'll just multiply this term for ease in finding out the coefficients. So that will be a into s square plus 2 plus b s into s plus 1 plus c into s plus 1, that is equal to 3s plus 1. Again, I'll just multiply the s so that comparing the coefficients is going to be easier. A square plus 2 plus b s square plus s plus c into s plus 1 is equal to 3s plus 1. Now I'll just finally write down the coefficient equations and I'll just give the final answer. If you're going to compare the s square terms, you're going to get a plus b is equal to 0. That's your first equation. If you're comparing your s raised to 1 terms, you're going to get b plus c is equal to 3. That's going to be your second equation. And then if you're comparing the s raised to 0 terms, you're going to get 2a plus c is equal to 1. So these are your three equations. A plus b equal to 0, b plus c equal to 3, 2a plus c is equal to 1. You can just solve these three equations and you will be getting the value of a, b and c. Okay, so I'll just give the direct values over here. The value of a will be minus 2 by 3, b will be 2 by 3 and c will be 7 by 3. So we can just substitute the values in your function over here. Okay, so I'll just substitute it over here. You'll get f of s is equal to, okay, let me just go back and check how I had given a, b and c. Okay, yes. Okay, so you have a divided by s plus 1. The value of a is minus 2 by 3. So minus 2 by 3 divided by s plus 1 plus the value of b is 2 by 3, 2 by 3s plus the value of c is 7 by 3 whole divided by s square plus 2. Now again you can see over here there are two terms. Okay, so you can just split it in the normal manner. So that will be minus 2 by 3 divided by s plus 1. You are just going to share the denominator to the both sides. So you have 2 by 3s divided by s square plus 2 plus 7 by 3 divided by s square plus 2. Now these are the formats which are familiar, which you are more familiar with. So you can just find out the values. Okay, you can just find out the values over here and you can just find out the inverse Laplace transforms. I'm just going to leave this to you. Okay, you can see that this is in the form of e raised to minus 80, and then this particular term is in the format of cos 80, and this particular one is in the form of sin 80. So I'm just going to give the final answer, and I want you to figure it out on your own since you have already studied these portions in your mathematics. So I'll just give the final answer over here and you can just check whether you're going to get these answers. Okay, you can just check whether you're going to get these answers. I'm not going to solve it over here. Okay, it is very simple. You have already studied all of these answers. Okay, so this will be your final answer. You can just check out the logic over here. Okay, now as the final part, I'm just going to give you two questions as an assignment. You can just try and do it on your own. Okay, try to find out the inverse Laplace transform of 1 divided by s square into s plus 1 the whole square, and the second question is f of s is equal to 1 divided by s minus 2 into s plus 2 the whole square. Okay, so please try and complete these two problems during this hour. You have 1 hour. The video is quite short. It's just a 15-minute video. Watch the videos and try to find out the inverse Laplace transform of the two problems which are given over here. Okay, so thank you everyone for watching this video. In the next class we can go through the RL circuit analysis. Okay, thank you.